Speed is of the essence in a mega factory. To produce 25,000 bikes in a day, every part needs to come together with speed and precision. At the Hero Mega Factory, both robots and humans work in harmony at the production lines to achieve optimum efficiency.
You will find a very good mix of automation and the manual workforce, which are marrying the two processes to the best of optimization. Wherever we need very, very high accuracies, repeatability, we have robots working there.
The automatic conveyors take all parts required to build a motorbike to the 11 assembly lines of the mega factory.
These are the part feed carriers, which is carrying one motorcycle equivalent part. This is the first stage where the overhead conveyor has got the frame body, where the electricals are fitted and wheels are kept on the side.
Each assembly line moves at the speed of 25 kilometers per hour. The workers, each with a specialized task, work in perfect rhythm to assemble a motorcycle from scratch.
I think rhythm is the most important in manufacturing activity. If you are able to build the rhythm, you can deliver as and when the customer requires the required product.
With a perfect rhythm, each production line manages to move a bike through the assembly line in 18 seconds.
While the assembly lines are busy putting the components of the bike together, the component testing lab of the factory is doing just the opposite.
Dr. Ramasubbu's job is to destroy them in a controlled manner.
If in motorcycle any one single part fails, it is a failure of the total system. So we take care each and every individual part, even including small spring also we are checking its life, and we are seeing that whether it meets its requirement or not.
Ramasubbu puts each and every component of a bike through a series of stress tests to make sure it won't fail in the most extreme of road conditions.
Whether the switch is failing or not, that we are confirming here. We are doing up to 30,000 cycles. We run this alloy wheel up to 1 million cycle, and the load which I am going to give, it is 3 times more than what my customer is going to do that. This is a lock and key test rig, and here I am checking that mechanical performance, electrical performance of my keys. This is the fuel filler cap test rig. Here I am checking the performance and endurance of my fuel filler cap. Shock absorber, we are doing up to 10 lakh cycles here. Okay, this part should not fail. That's why we are going up to 1 million cycle.
From a small spring to a tiny electrical wire, each and every part is put through 4 times more stress than it would face on the road. If there is a part that could fail, Ramasubbu is its nemesis. Today, Ramasubbu is mounting a motorcycle on a specially built treadmill.
It never ever should fail at customer end. So we want to ensure that throughout the life at the customer end, this part should not fail.
The treadmill will simulate various conditions a motorbike may encounter on the road. From bumpy roads to potholes, this bike will travel more than 10,000 kilometers to see if it can sustain the damage. And if that is not enough, Ramasubbu brings out his special machine.
This is a vibration generator. So this machine can simulate engine vibration as well as road vibration. So under this vibration, we are predicting the life of the component.
But testing is not something that is only done by At the endurance test tracks of the factory, specialist riders check on the rideability of the motorcycle. For 8 hours a day, the test riders take the bikes through various road conditions on specially designed tracks. In a year, each rider would have done enough kilometers to go 5 times around the planet, all in an effort to check the durability of their motorcycles.
Back at the research lab, a prototype of the newly redesigned engine is ready. In the pursuit of increasing fuel efficiency, the engine is sent to the engine performance lab.
Each engine prototype is rigged up to sensors, and computers monitor every bit of its performance. The engine exhaust is fitted with an electronic nose that analyzes the exhaust smoke for various pollutants.
In this lab, only the sturdiest and the most fuel-efficient engines will head out to the next stage, where the most fittest engine will survive. In a secret room of the research lab, engineers are bringing out their most secret weapon.
A purpose-built humanoid robot that mimics an Indian rider.
This robot is basically used for the vehicles when there is a requirement of long driving. That means if we want to test the vehicle for around say 30,000, 40,000, 50,000 kilometers.
This autopilot robot will simulate an Indian rider's driving habits of acceleration and braking, while the machine will simulate complex situations that the bike will encounter on the road.
Now robo is driving on the Indian road. Second gear, because the traffic is very slow. Now he is getting the clear path. So now again going to a higher gear. It's now third gear. And now traffic is smooth. It's changing to fourth gear. He is in the market now. So he's changing the gear. There may be some people crossing the road. There's a signal. Okay. Now it has come to the halt. Now it will again start. Once he gets the green signal, it will go ahead. Man can drive almost 8 hours in a day. So this can drive 24 hours a day. So we can accelerate the testing by 3 times.
The engineers can make their final tweaks to their new fuel-efficient engine that is due to come out into the market.